Okay, so this is the same problem like the one we did before. Example 4 in your reading assignment. Following the same steps, the problem is analyze the graph of a rational function. R of x equals x squared minus x plus 12 over x squared minus 1. So I'm going to go through the 7 steps and we'll be graphing this same function as I did before. There are a few differences in here. The first one is my numerator cannot be factored. So step number 1, my numerator cannot be factored. So I'm going to write it as x squared minus x plus 12. And my denominator can be factored, so it's an x minus 1 times x plus 1. So this is telling me the domain of this rational function is everything except the values -1 and 1. Okay, so that's letting me skip step 2 because I cannot simplify this, so it cannot be written in lowest terms. So whatever is given is the lowest term of this rational function. So now the next step is to locate step 3. Now if I go into step 3 again here, since I cannot factor this to find the x-intercept, to find the x-intercept, yes, you have to plug in y0 and solve for x. So if I cross multiply, this would become an x squared minus x plus 12 equal to 0. Now I need to figure out, I know that I cannot factor this, but now I need to figure out if I will get any real zeros. So let me do a quick check. I'm thinking of the quadratic equation. So negative b plus or minus. So this is the only piece that's going to tell me if it is a real number or not, right? So I'm just checking the b squared minus 4ac. So b is 1, -1, the whole squared, minus 4 times a is 1 and c is 12. So this is 1 minus 4 times 12 times 1 is 48. So this is giving me a negative number. So this is telling me that I won't have any real x-intercept. So I don't have to proceed further. So I would just say no x-intercept. Like later when we graph it, we can just confirm that there is no x-intercept. Okay. So my next step would be is to find the y-intercept. So to find the y-intercept, I need to plug in 0 for x. So 0 squared minus 0 plus 12 over 0 squared minus 1. So I would have 12 over -1 or -12. So yes, I do have an y-intercept, and the y-intercept is going to be 0, -12. So I need this information to graph. I know there is no x-intercept. I have to keep an eye on since I didn't have anything cancel out, I don't have to worry about a hole in the graph. But the next step is to look for the asymptotes. So to look at the vertical asymptote, again, I look at the denominator and I see the vertical asymptotes are at these 2 points where I have a x is equal to 1 and x equals -1 are my vertical asymptotes. So x is equal to -1, x is equal to 1. So these are my vertical asymptotes which I will need for graphing. Now I need to identify if it has a horizontal asymptote or an oblique asymptote. Again, because my degrees of the numerator and denominator are the same, it has an horizontal asymptote and it's going to be y equals 1 over 1, which is 1. So this is also the information I need to graph. Okay, so with all this information, before I graph, I just have to check if my graph is crossing the horizontal asymptote. So again, doing an algebraic check, the function given to me is x squared minus x plus 12 over x squared minus 1. I'm setting that equal to 1, which is my vertical asymptote, and I would cross multiply. So from here, times x squared minus 1. So x squared minus x plus 12 would be equal to x squared minus 1. When simplified, the x squared gets cancelled. So this would be negative 1, or I can say x is equal to 13. So yes, the graph crosses the horizontal asymptote at x equals 13. So the point that I have to put is 13 comma 1, and I have to make sure that I label that in my horizontal asymptote. Okay, so with all this information, let me graph it. So first, to begin with, I'm going to put the the vertical asymptotes, so negative 1. And let me label it a little bit more open so we can see the graph more clearly. So I'm having every 2 unit is my 1. So this is my x equals negative 1. And that's my x equals positive 1 equals negative 1, x equals positive 1. And then, okay, I'm going to have my y equals 1. Again, I will do that again with 2. The graphs are not drawn on scale, so approximation it. So 13 comma 1 is my place where the graph crosses. Again, I will approximate it. So let this point be x equals 13 comma 1. The graph is crossing the horizontal asymptote at that point, y equals 1. Okay, so with this information, there's no x-intercept, so that's something I have to remember. The graph is not going to touch the x-axis anywhere, okay? So let me go graph it. So I put the original function in here, x squared minus x plus 12 over x squared minus 1. I'm going to hit graph. Again, it's the standard viewing window, and here is it. Let me zoom in a little bit. So see here, if the graph is going on the right, it's never going to touch the x-axis. So zoom out. Okay, so this is going to zoom out, zoom out. Okay. Okay, so here I know the graph, since it's crossing the x-axis, and you see it blinking there. So the graph is coming down. As I know, it's never going to cross my vertical asymptote, but it's going to come and cross my horizontal asymptote. But then it's going to go closer and closer to the x-axis, but it's never going to touch the x-axis because there is no x-intercept. And also, there's one more point I forgot to mention, is the 0 comma negative 12. So assume that 0 comma negative 12 is my y-intercept. So on here, the graph is again tucking down to the vertical asymptote on either side, but it's never going to cross the vertical asymptote. And the third portion of the graph is over here. Here on this side, it's not going to cross the horizontal asymptote, and it will tuck up here on the vertical asymptote. So this is the graph of this function. And labeling few points like these ones here is it's required, like putting those points there, and and if you have any x-intercepts, labeling these also are very important. Okay, I hope you guys understood.